Hi everyone, my name is Chase Minardi, and this is my Week 8 spectral elucidation video for Group 2. I'm going to walk you through how I determine the structure of my unknown using its IR, 13C NMR, and 1H NMR spectra, along with my calculation for the degree of unsaturation, and how all the data led to a single structure. So to start off, we're going to talk about our degrees of unsaturation. The formula is 2 times the amount of carbons plus 2 plus any nitrogens minus any hydrogens minus many halogens all over 2. With it, we start off, we can see 2 times the amount of carbons, which is 5, is 10, plus 2 minus 10, the amount of hydrogens present, is going to be 2. 2 over 2 equals 1. So that means there's a 1 degree of unsaturation. So that means it's going to be either 1 ring or 1 pi bond. If we look at the IR spectra, which I'm going to discuss next, it shows a strong CO stretch, indicating a carbonyl group, not a ring. So our first group we're going to look at is the infrared spectrum. So to list off our most obvious thing that everyone should look for first is that there's no broad OH group between 2,500 to 3,300 centimeters inverse. Our first thing identified, our heaviest group, is going to be between 2,850 and 2,950. It's going to be that sp3 orbital with that CH group. Our next identification is going to be between 1,700 to 1,750. It is going to show that carbonyl group and that carbonyl stretch, that C double O bond. And then finally, the next group we can identify is between 1,500 to 1,300 centimeters inverse, and it's going to show a CO stretched. So from the IR alone, I can confidently say this compound is an ester with a single CO group, double O group, to be double bonded to an O group. Sorry about that. I want to be as accurate as possible here. Our next group we're going to look at is our 13C NMR analysis. So to start off with our heaviest group to our lowest group, at around 175, we do see that C double bonded to oxygen of an ester. Around 52, we see an oxygen attached to a methyl, and then around 35 ppm, we do see a CH group attached to a CO double bonded to an O group, and then around 19 ppm, we do see 2 CH3 groups, mainly the CH2, which is going to be the middle between everything. So with this thing, we can see that we finally have 2 equivalent methyl carbons near that 19 ppm. And then there's an isopropyl-like branch of 2 methyls attached to the same carbon. That's the main thing we can tell out of this functional analysis here. Now, around 1H, to start off, we can see around 3.7, we do have a chemical shift. It's an integration of 3H. Its multiplicity is going to be a singlet. And we do show a methoxy group, which is an oxygen attached to a methyl. Around 2.6, we do have a 1H integration. It's going to be a multiplicity. It's going to be a septet is the most accurate way to describe it. It's going to be a CH attached to that C double O bond. And then around 1, we do have a integration of CH, a multiplicity of a doublet, and then we do have 2 CH3s on the same CH. So overall, that's going to show a 3 to 1 to 6 integration, which sums to 10 protons, matching the C5H10O2 that we got shown earlier, and we're supposed to identify its structure. So assembling the fragments, we know that there's going to be a methoxy, there's going to be an ester, and there's going to be an isopropyl group. We can see the methoxy is going to be attached to the oxygen to a carbonyl, forming a methyl ester, and the carbonyl is bounded to a branched isopropyl group. That yields methyl 2-methylpropionate, also called methyl isobutyrate. It satisfies the molecular formula. The IR ester bands the 13C pattern and the 1H split in perfectly. Finally, you can see how it's drawn out. All the chemical shift assignments correspond to the structure and explains the 1 degree of unsaturation from the C double bonded to the oxygen bond. Overall, this is how I would ultimately draw it based on the evidence we're given. In summary, my compounds IR 13C, and 1H NMR data all support this structure. I've uploaded my completed worksheet to the PDF, and if you have any more questions, you can reach out to me or look how I came through this through my worksheet at the end of the day. Thank you so much, and like I said, if you have any further questions, please direct them to me.